Welcome to Brain Vision.
So, an alloy of iron and nickel, strong material, very low coefficient of thermal expansion, which is 0.2 times 10 to the minus 6 divided by degrees Celsius, per degree Celsius. A 1.6 meter long tabletop is made of this alloy, is used for sensitive laser measurements where extremely high tolerances are required. How much will this alloy table expand upon its length if the temperature is increased to increased by 5 degrees Celsius? And compare this to how much steel would increase. So we give an alpha value to denote the coefficient of thermal expansion. So in this case, alpha A for alloy is equal to 0.2 times 10 to the minus 6, and the unit is degrees Celsius to the minus 1. We give our coefficient of steel, so alpha S. Now, online values, so if you look up reference values, they vary for steel. The most common one that I seem to be familiar with is 13 times 10 to the minus 6. However, the solutions to this question require you to use the value of 12 times 10 to the minus 6 degrees Celsius to the minus 1. So in order to find the change of length, so delta L is equal to alpha times by change of temperature and times by length. So in the first instance with the super strong alloy, we so in part 1, alpha is the value of alpha A as given, delta T for both parts of the question. So actually we can say that delta T here is equal to 5 and L is equal to 1.6. So substituting the first alpha A into there, we have delta L A is equal to is equal to 1.6 times 10 to the minus 6. So substituting and putting that into an online calculator, so 1.6 times 10 to the minus 6, and delta L S for steel is substituting the 3 values into an online calculator. We get that the change in length of steel is 9.6 times 10 to the minus 5 equals 9.6 times 10 to the minus 5. And now to compare them, we will do delta LS over delta LA, and that is equal to 60. So the ratio is 60 times. I hope that makes sense.